Professor Washington is the Dean of the Henry Samuel School of Engineering at the University of California, Irvine, and his core areas of interest lie in dynamic systems, modeling and control in the following applications: design and control of mechanically accentuated antennas, advanced control of machine tools, design and control of hybrid electric vehicles, and structural position and vibration control with smart materials. And with that small bio, I'll let Professor Washington come up and do our introductions.
Our afternoon keynote is going to be given by Dr. Irene Petrick. Oh, by the way, you all enjoying the event thus far? Pretty good? Outstanding. Two very good sessions this morning, and we'll have a number of good ones this afternoon, starting with this one. So, Dr. Irene Petrick has over 25 years of experience in technology planning, management, and product development in both the academic and industrial settings. She is actively engaged with companies in their innovation and technology strategy activities, including working with 12 Fortune 100 companies, the U.S. military, and a wide variety of small to medium-sized enterprises. She has also authored or co-authored more than 120 publications and presentations and has presented road mapping workshops and master classes in the US, Australia, Canada, Taiwan, and the UK. So without any further ado, Dr. Irene Petrick.
The organizers asked me to come and share my ideas with you about a couple of things. One, sort of the future of where I see manufacturing going, and the other is some techniques that I use with companies that I work with to try and figure out how to go from tactical decisions to a more systems engineering approach. Okay, so the title is The Rising Digital Intensity of Manufacturing. And it's really what I want you to think about, and I've aimed this for the manufacturers here. It's really what do we need to do to go from where I stand now, understanding the competitive dynamics that I see, to where I'm going to need to be 5 to 10 years from now, and what does that really mean to get ready to compete? So I was teased when the organizers saw this. You don't have to speed read this. This is my way of summarizing what I'm going to say, so just ignore it. Okay. So we heard a lot this morning about the state of manufacturing. And I don't think we can dispute those statistics. But manufacturing life as we know it, I believe, is going to change. And it's going to change in some really important fundamental ways that we can either see as an oh my goodness, or we can see as a set of opportunities. I'm going to put on my rose-colored glasses and my pointy-headed academic hat and say that I'm going to be very, very optimistic. So the first one is the exponential pace of change. In the digital world, we've been seeing Moore's Law forever. We're going to now see Moore's Law fundamentally change the physical manufacturing world too. And I think we're unprepared for that. The second one is that I think we have the stable supply chains that we've grown to know, love, or hate, that we've gone to model, that we've gone to contractually understand and sell into. Those roles and rules are changing. And in fact, we're going from stability and predictability to ecosystems that are highly unpredictable and highly collaborative. And our practices about supply chain integration are not about being flexible, and they're really about being predictive rather than reactive. This is one that not surprisingly, I'm on the faculty at Penn State, and I was in industrial engineering, and I moved to the College of Information Sciences and Technology. And I moved mainly because digital technology is at the center of everything right now. Now, you might not see that yet, but I believe it is. Because digital technology is at the center of everything, IT sophistication is not a luxury. IT needs to have a place at the strategy table in a systems view of the world. So if I haven't lost you yet, here are some assertions. Oh, and please interrupt me at any point in time. I'd love to have this be a conversation rather than a talk at 'em. First assertion is that 3D printing or additive manufacturing isn't over the horizon, it's on the horizon. And because of that, we're going to achieve multiple material sophistication. And that's going to happen in ways that are going to change how we think about building stuff. Because right now, we don't have the ability to sequentially layer the functional capabilities across a part. And because of that, we have thought about parts as tangible, single pieces. And we're going to have to now think about them as molecules. We're going to have to think about them as layers. We're going to have to think about them as very complex interactions between layers. And we don't know how to test that. We don't know how to design for it. We don't know the process parameters that go with it. So there are a lot of challenges out there. Now, with this said, how many of you are doing additive manufacturing? This is the audience participation part after lunch. Okay, good, good, good. How many of you are buying from somebody who's doing your additive manufacturing? A couple more, okay. So there are two kinds of additive manufacturing, and we talk about it as if it's the same thing. There are polymers, and then there are metals. The polymer stuff is really already here in many ways. The metals, not so much. We've got a lot more to do. And in fact, there's now food and a whole bunch of other organic, quasi-organic things that we're starting to do. I talked about the roles and responsibilities of this traditional supply chain becoming obsolete. Obsolete is a pretty pejorative term, and I'm not using it lightly, but I believe that. Competition will come from unexpected participants. Generally, if you are working in a relatively comfortable area where you know your competitors, you look left and you look right, and you understand the competitive dynamics. I'm going to argue that those competitive dynamics are going to be turned upside down by 3D manufacturing, because we're going to change what it means to be a designer, we're going to change what it means to be a manufacturer, and those pesky entrepreneurs are really going to make you crazy. All right, here's one that I've written pretty extensively about with my colleague Tim Simpson. We have competed in the economy of scale model for decades. I have variable cost, I have fixed cost, and I have to manage those very carefully. I have large footprints, and I have to manage that very carefully. Economies of scale are going to sit side by side with what I call economies of one, where everything is a variable cost. And that's going to be enabled through 3D printing also. Finally, and this is where my technique comes in, the piece that the CNMI asked me to talk about also. Because of all of these changes, we can't just perturbate a system in one place. We have to understand what the system's implications are. And to do that, we really have to understand the decision space much more broadly and the opportunity space much more broadly. And I'll finish this talk with a quick example of strategic road mapping and how I think perhaps it will add some value to those of you who are really going to try and crack this nut. Okay, so let me tell a little different story about manufacturing than you heard this morning. I spend a lot of my time thinking about trends. And it's not just the obvious trends, it's the way these trends come together. So I'd like to talk about 5 trends today. The first one really is technical high-performance computing enables complex design and simulation. If we're not going to physically make things all the time to experiment, then how are we going to experiment? How are we going to look from the outside of a part or assembly to the inside, to the functionality, to the material properties and their implications for the functional characteristics? Well, it's all going to be simulation. And that simulation, as the parts get more complex, that simulation is going to get more complex. And we're already seeing benefits from high-speed computing in small to medium-sized manufacturers. The second trend here, additive manufacturing attains viability for multiple materials. It's not too cool or too sexy to lay down material of one type. It will be really cool, however, when we can lay down materials of multiple types and we can predict how they will interact. We can build scaffolding for organs, introduce stem cells, and build our own organs. This stuff is in the research labs. It will come into production. So we're not here yet, but that's the second trend that in the next 5 years is going to drive a lot of change. The third trend, cloud-based solutions, reduce administrative overhead for smaller enterprises. How many of you are working in the cloud? Okay. When I ask that question 5 years from now, every hand is going to be up. I firmly believe that. Small to medium-sized manufacturers in particular have been slow to go to the cloud, partly because they don't have the internal IT capabilities to understand how to spec the systems in the first place. We're seeing companies compete with very, very large, very established, very, very sophisticated logistics systems by snacking in the cloud. If I can bid things like General Dynamics, if I can deliver like Boeing, if I can predict like FedEx, I'm all of a sudden going to have the imprimatur of sophistication that currently many small to medium-sized manufacturers struggle with. The fourth one, social media-based funding. This is one of my favorites. Kickstarter and other kinds of social media. We're still at the very nascent part of this uptake, but it's coming, and it's going to come in a big way. Despite the fact that Oculus Rift got bought by Amazon and all those people who invested aren't real happy, we're still going to see more and more of this kind of funding. And then there's that fifth one, internet-savvy do-it-yourself hobbyists. How many of you are internet-savvy do-it-yourself hobbyists? Oh, stand up and take a bow. You're going to lead a revolution. These are the people who don't necessarily know what's not possible. And the younger they are, the more interesting problems they think are reasonable to challenge. We see 3D printers in high schools, in grade schools. When you talk about STEM, 3D printing is going to make manufacturing sexy again to a whole new generation. We're going to have a problem in the middle because we have a lot of people who have not gone into manufacturing, but even in my own classes, and I teach design and innovation in the digital world, a lot more students are coming to the digital world because they want to play with some of these things. So when you take those 5 trends together, when you take those 5 trends individually, they're interesting. When you take those 5 trends together, I believe the future scenario is IT-driven design and production enables economies of one. If I enable economies of one, what are you competing against? If I enable economies of one in a cost-effective way, where's your source of competitive advantage? It's not going to be in the same place it is now. Okay, so what this does is this creates 2 dramatic shifts. First of all, design and production is now experimentation. Design and production isn't about a predictable model that I know exactly what processing parameters I need to have, exactly what finishing. Because I have design and production as experimentation, my designer has to really be holding hands with my manufacturer in a way that we haven't seen in 2 decades. If you're a manufacturer, this is exciting because this now makes your process knowledge critical as a differentiator. Most of you aren't prepared to sell based upon that critical differentiator. The other thing that it does, which I think is pretty cool also, is it creates the rise of what I'll call the any man or the any woman. But this is somebody who will be enabled with tools that are easy to use. We won't have very sophisticated, very, very difficult engineering tools that put a barrier between people who want to create and people who know how to create. In the next 5 years, these tools are going to become much more simple. I can already take an iPhone, and with an app, I can sequentially take a picture of an object all the way around. I can upload that to a cool little app that will actually build me a model that I can load to my printer. It's not quite seamless. It's not very pretty yet. But it's coming. So these are not things that are going to be unusual. These are not things that are going to be unrealistic. And in fact, the younger people are going to have a much stronger sense of how to deploy these than your technically capable, highly talented engineers. And I think you really, as manufacturers who want to compete, you really need to be thinking about those capabilities in a very different way. Am I driving you crazy, Mr. Cameraman? Sorry, I'm a pacer. So let's talk about a couple of other trends. One of my favorite books, if you haven't read it, is called Big Bang Disruption. Anybody? Oh, there's one. You know, you've had your hand up 3 times now. You get a special. Thank you. Okay, Big Bang Disruption is all about the changing nature of competition. It's a great book. I don't own any stock in it, but if you haven't read it, buy it. It's great. Nunes and Downs talk about a couple of really important characteristics that describe this new competition. First of all, the exponential growth rate of technology change. We've seen it in the digital world. It's going to now impact the physical world in some really meaningful ways. And they talk about that as being a really important piece to this part right here, which they call the singularity. It's all about experimentation. It's about finding what works, finding what delights the customer, finding what solves a problem in a cost-effective way, and then introducing it into a market that will be characterized by incredible growth, leveling out, incredible decline, and then entropy. For those of you who are familiar with Ev Rogers' typical bell curve adoption, where you have that lovely bell curve of adoption, these authors are saying that this whole thing takes place in the first half of that curve. In fact, their comment is that time to market will be superseded by time in market, which means understanding what your derivative products are at the outset, understanding who your derivative customers are at the outset will be critical to how you execute those experiments. So experimentation becomes really, really, really important. The third one is sort of interesting because it goes against what many of us have believed to be our source of competitive advantage. Many of us who are engineers were raised to believe that if I can design something new and patent it, I have intellectual property that protects me and my company and my business for some meaningful period of time. What these 2 authors posit is that it's not about the IP only. It's about being able to borrow IP off the shelf from multiple places, recombine it in ways that are new and compelling. Well, that suggests new design paradigms, and it suggests new business models. We have been at the last decade, we've seen a lot of manufacturing go to manufacturing/service. You're going to see 3D printer hubs that are going to be complete service, and then who knows? So we're going to see digital business models that we haven't even thought of yet. And I'll come back to that point in a moment. How am I doing on time? I'm good. The artisan entrepreneur. So let me sort of put this in a historical context. We started with artisan entrepreneurs who lived in a local environment, who serviced local customers using local materials. Well, along comes the Industrial Revolution, and we actually have the consolidation of capital, and we have really centralized production and delivery. Along comes information technology, and we say, wait a minute, I can now source this to the cheapest place because I have all of these logistics things driven by information technology that enable me to take every piece of efficiency out of this system. And this is really what we're used to. This is our competitive understanding of the world. But our customers' understanding of the world really is a little bit different. I want things my way to fit my body exactly when I want them, made of the materials I want with the functional properties I need. And I really don't care what you have on your shelf because I want what I want. I've seen it in music, I've seen it in entertainment. It's not a decade away for many, many, many products. So what does that mean? Well, that means that the internet-based business processes and designing virtual manufacturing production will actually do what I think is the coolest part of all. It's going to return manufacturing to the garage. And you in California know all about that. But the neat thing is, when I return it to the garage, I don't force it to get bigger and bigger and bigger and bigger to continue to be successful. And that's the change. So you're going to see competitive advantage through economies of one, and these two are going to coexist. Woe to the manufacturer who has to do both. And there are going to be some of you who will need to, or at least consider it. Okay, so Arthur Clarke, the famous fiction writer, British fiction writer, says that any sufficiently advanced technology is indistinguishable from magic. Well, we're not quite at the magic stage yet. But many of us are thinking about it like that. We're going to see parts go from what used to be a prototype to being a finished product in one pass. Perhaps two if we have to heat treat it or do other kind of surface finishing to get the properties we need. More interestingly, we're going to see shapes derived from nature that have all of that evolutionary power behind them in terms of strength to weight and other kinds of properties. We're going to be able to make these in ways we have not been able to achieve. So what we think of as a finished design, what we think of as our design teams are going to change. If you don't have a biologist or naturalist on your team and you want to do this, you might want to think twice. Who would have predicted we would need a naturalist on our team? I think the smart ones will. But is that really sufficient? Well, elsewhere I've spoken about the ecosystem underlying a lot of these things. The way we deliver things is going to change. The way we design things is going to change. Printer hubs are going to change the way we have variable versus fixed costs. All of that's going to happen, and I'm not going to talk about that today anymore, in the interest of time. However, let me leave you with a sort of a framework that I use to try and build these things out. First of all, I think you have to have a call to action. What is it about this new world that either threatens you or excites you or keeps you up at night? How do you think about where you might want to be? And that's that whole idea of strategic intent. Then you have to look at, if I have this intent, what's the external environment look like? And I'm going to warn you, y'all have blinders on. You don't know it, but you do, because the people who are going to be manufacturing successfully in this new digital environment aren't people you're traditionally looking at as competitors. They're going to be much smaller, they're going to be much faster of fleet, they're going to experiment like crazy and drive you nuts. Okay? You have to then think about, okay, what are those trends? I gave you those 5 trends at the beginning. I probably had 100 trends when I started. 100 trends that could possibly come together, but I had to prioritize which ones I thought mattered in the world I want to play in, which is digital design. The other thing, though, that you have to think about is, what are the critical few trends that I really need to pay attention to? And oh, by the way, how do I monitor them? The other thing that gets very interesting is that we have become, as engineers, very good at problem solving. We really stink at problem finding. And this is a world all about problem finding, because your customers don't know what's possible. And it's just like the iPhone of years ago. It's like the carriage or the car of centuries. I didn't want a faster horse, I wanted to go faster. So our customers are going to be rooted in expectations and assumptions, and we have to identify the assumptions that they hold and the assumptions that we hold as designers. Finally, we have to think about, if these are the things I want to do, what technical things do I have to have in my arsenal? I still have to reduce this somehow to tactics. How do I go from strategic intent to tactical operational investments? Well, the first thing we can think about is, what are the technologies that cross multiple potential opportunities? And we see a lot of technology roadmaps coming out of this. The second thing that we need to think about, though, and this is the one that's going to get us in trouble. Traditional manufacturers are going to need to be thinking about, what's the value prop? What's my new channel to market? How do I monetize various paths to market? Oh, by the way, what's my ecosystem strategy? Who matters in my ecosystem and what do they bring to the table? And then finally, based upon who matters, who do I partner with and how do I partner? Our contractual, legal kinds of mechanisms for partnering are obsolete in this new world. Okay. And then we have to get really comfortable with running as fast as we can, falling down, not me, of course, falling down and getting up and running faster. Because it's all about what I call emergent behavior. I can't predict where I'm going to be a year from now with certainty. And if you can, then you're probably aiming in the wrong place if this is the world you want to play in. So let me end with, and then leave time for questions. So roadmaps, composite roadmaps, or what are called product line roadmaps, try and bring this all together into a single view. And it says basically I have markets that I have to think about entering. I have products into which I'm going to enter. I have technologies and technology platforms that support those products. To get to that technology, I had to do basic and applied research, and I had to know where those things were happening in my supply chain. So we put together something like this. We have basic research projects that we do ROIs on and say what technology are they enabling, what are the products that I'm going to enter into those markets, and what am I going to expect as revenues? Well, that's fine, except that if you're really experimenting, you want to be thinking about the next technology platform simultaneous. You want to be thinking about the next set of markets and derivative products. You want to be thinking about failure, and how do I have enough technology products in my pipeline, enough experiments on there, that I'm able to fail without shooting myself in the foot. Finally, you want to be continuing to move that forward. This is no longer my 2-year plan. This is my rolling plan. And there are 2 major pieces that I think from a 3D manufacturing, additive manufacturing, digital kind of manufacturing. The first is that I really have to understand adjacencies to my current markets. I have to understand adjacencies in terms of features, in terms of materials, in terms of envelopes and footprints. And I have to be thinking of those constantly. The other thing that we don't spend much time at all thinking about is capabilities. A couple people alluded to it earlier today in the first panel, but information technology specialists aren't going to be a luxury. You're going to think about modelers and simulators that are going to be critical to your success. And new business models are going to have to be something you're constantly thinking about. All of those things take capability building. No offense, MEPs. It takes capability building beyond our current understanding of the capabilities needed to be successful. And even though I'm in academia, we don't know what's going to be successful necessarily. So I stand up here and sound as if I know it all. Well, 10 years from now, we'll know whether I was right or wrong. The difference between a visionary and a crackpot is hindsight. I'm sufficiently thick-skinned to put myself out there. But let me leave you with a couple thoughts. Okay, the future is really not far away. We're doing a lot of work around 3D manufacturing that's already in use as replacement parts in metals, as fashion and other kinds of wearables, as foods. That really is 3D printed bacon, and actually confectionaries are leading the way in some of the art to 3D kinds of stuff. Oh, by the way, don't forget that gun that always gets us in trouble. We've got very functional kinds of pieces that are now replacing heavier things with lighter, more naturally designed and envisioned kinds of parts. And then we've got all of those wonderful applications that are just my size. Here is an ear. Whoops, here is an ear. Here are prosthetics. And this one you can't really see as well, but this is actually a prosthetic that's a honeycomb, which is very, very lightweight, very, very easy to use, and very, very strong. And then we're actually seeing quite a bit of work around topographical kinds of things, buildings and architecture. So this is crossing multiple kinds of sectors. So competing in the future. Understanding your competition means knowing who your competition is. And I think many of you are looking in the wrong places if you're like some of the companies I'm working with. The tight link between design and manufacturing needs that the whole nature of collaboration is going to change. I think if I was the manufacturer right now, I would think that was the most exciting part of all. I'm going to have a seat at the design table doing meaningful things rather than chunking out parts. Big picture thinking will be an essential skill, and the interrelationships between market opportunities, product opportunities, research, and capabilities must be known up front. The interrelationships, not the end results. And if that didn't scare you, I'll take some questions. So imagine this is time on the horizontal, okay? And it's called the shark fin. It's the name of the model. The shark fin is actually the number of customers over time. So at the beginning, you have little bumps as you experiment. You get something that actually gets exciting in the market. You get a product that excites the market right about here. You start to see huge amounts of uptake in terms of the number of customers, the growth in the number of customers who want to buy your stuff. It quickly reaches saturation, and you see a drop in the increasing number of customers. You still have a lot, but it's not a growth rate. And then you're moving on to the next thing. The authors argue that by the time you get to entropy, you better be cycling back and already be doing experimentation. We have a lot of very well-understood, well-established ways of educating, and they're along disciplinary lines, not interdisciplinary lines. I think we need to have a lot more problem-based learning. In my own classes, I throw out problems, and we work through coaching as opposed to specific kinds of labs, for example. But academics really does need to change. I think students coming in the next 5 years from programs in high schools that have been very hands-on, I think that we'll see some changes. But we're partially at fault, and we don't like change. The problem with project-based schools in general is generally that experimentation is undervalued and failure is undervalued. We have certain metrics that we're driving toward. If I'm doing experimentation, schedule, cost, quality can't be the only metrics that I use. And now I'm going to fall on my sword. I'll be around, though, for a while. I'm getting the hook.